So yesterday we have completed this part. Do you have any doubt regarding this topic? Based,
No, ma'am.
okay.
No, ma'am.
No,
No,
ma'am.
ma'am.
This is Carnot map. I have already discussed about this, the rule of solving the Carnot map. Why we are taking the gray code here instead of normal binary code? Because we are using this Boolean rules when there are two variables, suppose AB plus AB bar, then you can cancel the B literals. How? By taking this A as a common term in
Complementary law.
complementary law. So x plus x bar equals to 1. So we can drop out this variable in this way. That's why Carnot map is drawn in this style. For two variable, it is for three variable, and it is for four variable. So you have any doubt, you can ask me regarding this part. Carnot map.
No, ma'am. No doubt.
Now here is the conversion table. Easily how we can convert any decimal number into the binary form, at least up to 15. This is a very easy way. Okay. See, already you have know that
Ma'am, this is four variables.
four variables. Suppose for four variables, four inputs are there, so we need up to 15, right? 0 to 15, because there
Yes,
are
ma'am. Yes.
variable 15 combinations. So what will be the combination? Just a minute, just see this. This is binary code. Binary code is always weighted code. Weighted means each place value has some weight. So you know, in binary number system, the base is 2. So in unit place, it has a value, it has a weight, that is 2 to the power 0, that is 1. And if we go towards left, it will be 2 to the power 1, 2 to the power 2, 2 to the power 3, and then 2 to the power 4, and 4 more. So in this way, what will be the weight for unit place? 2 to the power 0, you know, 1, 2 to the power 1, 2, 2 to the power 2, 4, 2 to the power 3, 8. So in this way, we can remember this 8421 code, 8421 code for 4-bit representation. Okay. So maximum using this 4-bit, that is when all the bits will be 1, the decimal value will be 15. So this is the representation of corresponding binary value of the decimal value. So decimal value 0, if we represent it in the 4-bit binary form, it will be obviously 0000. And 15, that will be the maximum value when all the bits are 1. So for 4-bit representation, it will start from all zeros and it will be end at all ones. Then how you can get this value from this weight? When all the value will be 1, what will be the total sum? 8 plus 4 plus 2 plus 1, because all the bits are 1, and if we multiply 1 with the weightage value, then you will get this. Then add 8, 4, 12, 12 plus 2, 14, and plus 1, that is 15. So in this way, 15, it will be 1, 1, 1, 1. Okay. And by division method, you can also convert it, but at a glance, we just represents 15. 15 means how many bits are there? It will take 4 bit in binary form.
4 bits.
So
Yes, ma'am.
all will be 4 ones. Now 14. 14 means 1, 1, 1, 0. See, 8 plus 4 plus 2. It will give us 14. So it will be 0. This place value, this bit will be 0. So here it will be 1, 1, 1, 0. 8, 4, 8 plus 4 means 12, 12 plus 2, that is 14, and here it is 0. So 14 means equivalent binary is 1110. Clear? Take another
Yes,
value.
ma'am.
Suppose 10. 10 means it will be 1010 because here the weightage value is 8. Here it is 2. So if we take these 2 bits as a 1 and other 2 0, then what will be the condition? Then you will get 8 here, you will get 2 here. So 8 plus 2 give you 10. Clear?
Yes, ma'am.
And another thing is, when you start from 0, in binary number, there are two symbols. First write 0, then 1. Then what will be the next number? Suppose 0 to 9 is there. Then after 9, you just write 1 0 and it will be end with 1 9, 19 in decimal number system. Clear? In decimal number systems, how many symbols are there? 0 to 9?
0 to 9. Yes, ma'am.
So after 9, what will be the digit? What will be the number? 10.
Yes, ma'am.
So 10 means 1, then 0.
1 then
Here,
0. Yes.
here the two symbols, 0 and 1. Then what will be the next number? 1 0.
1 0.
Then 1 1. So these are the two values, 1 0 and 1. Then what will be the next number? Take this 1 0, 1 0, 1 0. Then it will be 0 1. Then next combination it will be 1 0 0 1 0 1. Then what is the next digit here? 1 1. Then place 1 1 1 1. What will be here? 0 1. Then after 1 1 it becomes 1 0 0. So write 1 0 0. Then write here 1 0 0. Then it will be 0 1 just. Then you will get 8 9. After 1 0 0, here it is 1 0 1. So write 1 0 1 1 0 1. Add 0 1. It will be 1. It is wrong here. Okay. It will be 1. Clear?
Yes, ma'am.
It will be 1.
1 না হলে তো 11 আসবে না।
Yes. And next digit is 1 1 1. So write 1 1 1 1 1 1. Then add 0 and 1. Because these are the two possible combinations, adding 0 and 1. So you will get 14 and 15. So these are the representation of decimal numbers into 4-bit binary form. Is it clear though? Is it clear?
Yes, ma'am. Yes, ma'am.
Okay. Now next. How we can put the min term into the kernel map. Suppose truth table of 3 variable digital circuit is given. Truth table of a 3 variable digital circuit is given. 3 variable means there are 3 input variables of the digital circuit and y is the output. So truth table is given for designing the circuit. So from here, when we represent the truth table into the kernel map, how we put the value here? You know, as there are 3 input variable, we will draw this kernel map having 8 cells. 8 cells, because 3 variable means 2 to the power 3, that is
2 to
8
the power 3.
combinations. So you know, in this way you can write, or another representation is, I have taken this type, this pattern. You also can draw the kernel map for 3 variable in this way. Okay. So now we are following this pattern. This is the combination 0, min term position 0, here 1, this is 2, 3, 4, 5, 6, 7. So now you know this. first write 0, 1, 2, 3, 4, 5, 6, 7. This corner. Okay. That is the min-term positions. Min-term positions. First mention the min-term positions. Then see for which min-terms the output is 1. Because min-term means we are taking the 1 as a true output of the circuit. So here for 4 combinations, 4 input combinations, the output will be 1, and for other combinations, other 4 combinations, the output is 0. So first identify for which min-terms the output is 1. You can identify it easily because you know the representation, because
Yes,
it corresponds to 0, 1,
decimal. Ma'am,
2,
the
3,
decimal.
yes, 4, 5, 6, 7. This is 3 bit. So here started from 0, 0, 0 and end with 1, 1, 1. This means 0 to 7. Okay. So this is M1, M2. Here it is M4 and M7. So M1, these min-term positions will get the 1 value. Min-term 2, get 1. Min-term 4, get 1. Min-term 7 will get 1. Then what will be the other cell value? It will be 0. 0, 0, 0, 0. Clear?
Yes, ma'am.
So now from the truth table, we can place the min-term value here. So this truth table is now represents the this Karnaugh map represents the output of the circuit. This is the K map for output 1. Now, how we can solve this at a glance? Just a minute. Anishi? আচ্ছা ঠিক আছে, আমি ক্লাসে আছি, আমি পরে কল করি, দেখে তোমাকে। আচ্ছা ঠিক আছে। Okay. Now, this representation you know, na? Just skip this part. Representation
ma'am.
of sum of product on K-map and representation of product of sum on K-map. I hope you know this value.
Yes, ma'am.
Again, I come back here. Simplification of SOP expression using K-map. Now, so next thing is how we can simplify the expression with the help of K-map. Okay. Now here, one output expression is given for you. So y equals to summation of min-term 1, 3, 5, 7. You should minimize the expression which is given here. And ultimate purpose is, after minimization, you should realize the circuit with the help of basic logic gates. That is the objective. Now, how you can minimize the expression using K-map? Problem is given. Up to this is given. Okay, minimize the following expression using K-map. Expression is given in this form. Y is a variable function of A, B, C. Sometimes only you will get y equals to summation of min-term 1, 3, 5, 7. Then how many input variable will be there? You can guess from this part. Okay. Find out the maximum value of the min-terms. Okay. Here it is 7. So 7 is the maximum value for 3 variable.
Yes, ma'am.
Okay. If 7 is not there, suppose 5 is there, then how many input variable will be there?
4.
4. Why 4?
Ma'am, because we have to start from 0. 0, 1,
Yes,
2, 3,
no.
4.
This is min-term 5. Min-term 5 means?
Oh, acha, min-term 5. Oh, acha.
The combination is 101. Okay.
101. Yes, ma'am.
1. So how many input variables are there?
3.
3. Suppose 5 and 7 is not there. Only 3 is there. 1 and 3 is there. Then
2.
2. Because for 2 variable, 3 is the maximum value. 0 to 3, right?
Yes, ma'am.
Yes, ma'am.
Okay. So if this pattern is not given, suppose y is a function of ABC, only you have got y equals to summation of min term 1357. Then first you check how what is the maximum min term value given in this equation. So here it is clear from this expression that the output is a function of three input variable ABC. Now, as it is a function of three variable, first thing is draw this Karnaugh map, then represents in this form. Why in this form? It is for 0, 0. It is for 0, 1. It is 1, 1. This is for 1, 0. And here it is for 0 and it is for 1. Is it clear in this form?
Yes, ma'am.
Okay. তাহলে first thing is take most significant bit here, write A bar A. Then for next 2 bit, C is the least significant bit. So write BC, not CB. Okay, write B, then C. Then write B bar C bar, B bar C, B C bar, it will be here, then BC. Following 0, 0, 0, 1, 1, 0, 1, 1. And then mark the cells. How many cells are there? 8. Then mark the cells with the corresponding min term value. You know 0, 1, 2, 3, 4, 5, 6, 7. Then from this equation, take for 1, 3, 5 and 7. 1, 3, 5 and 7. Put the value 1 in the corresponding cell. And for the other cells, put 0. Here it will be 0, here it will be 0, here it will be. Then how we can solve the equation? See, here these two are adjacent, these two ones are adjacent, these two adjacent, and these two are adjacent. And in the another way, these four ones are adjacent. So these 4 cells which are adjacent contains 1. So you can make a group here. And this grouping of 4 adjacent cells known as quad. When 4 adjacent cells contain 1, mark in this way, these 4 adjacent cells make a group, and this kind of grouping of 4 adjacent cells is known as quad. Okay?
Yes, ma'am.
So how many product terms are there in this equation? From this representation, you know, in the standard sum of product form, there are 4 product terms, right?
Yes, ma'am.
And for each product term, the output will be 1. So now, when we have taken this group, just you can write y equals to C. This is the explanation, but this explanation is not required. Okay. Just you can write y equals to C. How? See, for these two, these are horizontally placed, these are vertically placed. From here, you can drop B bar, because all the product terms are in A or form or summation in between them, because it is sum of product form.
Yes,
This
ma'am.
equation is given.
Yes,
This, right? Then from these two adjacent cells, we can drop the literal B. Why? If we take C as a common variable, then
Complementary law.
B plus B bar give us C only. And from here, check vertically. Here, A
Again,
and A bar
again that
is
law.
here. So A plus A bar give us 1. So which variable is left here? Only C.
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 So by taking these 4 adjacent cells, you can drop out 2 variable A and B. Only Y equals to C. So actually the output Y is a function of C only. If C is 0 or C is 1, you will get the answer. You can check it by preparing the circuit. So how you can explain this? For row 1, what are the corresponding min term? A bar B bar C, A bar B C. Clear? For this first row, how many
Yes,
min
ma'am.
terms are there? 2. So from
Ma'am,
here, step by step, following algebraic method, A bar C common, B plus B bar give you 1. And for row 2, you can write for 5, that is A B bar C, and here for 7 A B C. So A B bar C plus A B C. So here AC is common, B plus B bar give you 1. So by taking these two for row 1 and row 2, again you will get A bar C plus AC. So how many min terms are there? Here 2 min terms, here 2 min terms. So total 4 min terms which are in or in between them. So you can write in this form A bar C plus AC. So by taking this C is a common as a common variable, then you will get A plus A bar and ultimately you will get C. So this methods is basically algebraic method, but here we have got this just in a single step from this graph. So which method is easier for us?
Okay, ma'am.
K-map. And the drawback of algebraic method, one of the most main drawback that we have seen in the algebraic method, that after the simplification we have a doubt whether it is the last step or is there any other steps that by using that step we can minimize the expression further, right? So
Yes,
you
ma'am.
can overcome that drawback by using the K-map. So this is one examples. Now another example is for you. First, try to this in your copy and check the result. Okay, don't see this part here. Just try to this in your copy and do this. I am giving you the time, that is one, you can take 1 minute.
Ma'am, problem 2.
Problem 2, just honestly don't see this part. Okay, then I will explain. If you can't understand, then I will explain it. Just take this part. 0145. Have you got the result?
Yes, ma'am. B bar.
Okay. Now, see, for 0, 1, 4, 5. First thing is, if it is given y equals to summation of min term, not ABC is given, then from 5, maximum value is 5, and you know, if we represent 5 in binary form, it is 101. So it will be 3 input variable. The circuits have 3 input variable ABC. So draw this Carnot map. Place 1 for 0, 1, 4, 5, 0, 1, 4 and 5, and put 0 for the other cells. So you have got 4 adjacent cells are there, and from here, as A and A bar both are there, you can drop this literal because A plus A bar give us 1, and from this part we can drop the C literal because C bar give us 1, so only B bar will be there. Is it clear?
Yes, ma'am.
For others?
Yes, ma'am.
Yes, ma'am. It's clear.
Now, another way how we can form the quad in a 3 input 3 variable K map. Another option is there 0 to 46. So 0 to 46. If we consider this graph as a paper, this graph is drawn on the paper, and if we fold the paper, both sides will come at the same line. If we fold this part, okay, then you have seen that these two cells and these two cells are adjacent. So in this way, these two ones and these two ones forms a quad and mark in this way.
Yes, ma'am.
Okay. So what will be the output? Binayo,
Ma-
what will be
Ma'am,
the, as A bar is there, you can drop the literal, and from this
ma'am,
two
it will be treated as a quad
quad,
after folding the
obviously, because
after.
these
Uh,
two and these
uh,
two
yes, ma'am.
forms a quad. And what will be the output? See, B and B
C
bar
bar.
give us 1, so it will be C bar. I hope it is clear from this
From
diagram.
this diagram. Yes, ma'am.
Clear?
Yes, ma'am.
Okay. Now go for the next one. Problem 4. 0 to 4 is given. 0 to 4 is given. Then what will be the output?
Yes,
Sia
ma'am.
is there. Sia, are you there?
Yes,
Is it clear?
yes, ma'am. It's clear.
Shunayana?
Ma'am.
Shunayana?
Yes, ma'am, it is clear. Yes, ma'am. Yes, ma'am.
Okay. Actually, in the last class, only 8 or 10 students will be there. Total strength of this section is 23.
23. Yes, ma'am.
Okay. So now lateral will come and join. Uh, it will take time. But just for you, this is
Ma'am,
the information. Yes, bolo.
হ্যাঁ ম্যাম ম্যাম এখানে ম্যাম কোয়াড কি এখানে হচ্ছে না তো ম্যাম মানে
কি
এটা কি
হচ্ছে আমি বলছি, জাস্ট আমার কথাগুলো শুন।
ওকে ম্যাম
Just see, this subject is very very important for you. All subjects are important for you, but you should understand that this is a professional course. You are doing the engineering in electronics and communication engineering, and in the third year you should be prepared for the campus interview, and you should get ready for the industry. And so if you miss this class or other class, you can't understand the next paper, which is very related with this paper, that is microprocessor in the fourth sem. You can't understand properly the computer architecture, which is in the fifth sem. then you can't understand the digital VLSI, which is in the 6th sem. So all these 4 subjects are related with this digital electronics. And in this way, other subjects are also related with some papers. Okay, so please try to attend or join in this class and try to clear each and every concepts for these subjects for each topic. Okay. Is it clear?
Okay, ma'am.
After third year, na, just maximum thing is lab oriented or project oriented, and for the 4th year, the whole time is just for the preparation or for attending the campus interview. So up to third year, up to 6th sem, it is very, very important because you are in now 2nd year. You will get 2 semesters, and in the 3rd year, you will get 2 semesters. So these 4 semesters are very, very important. Okay. So please don't miss the opportunity to get a good job at the end of the 3rd year. Please. Okay.
Okay, ma'am.
Now see, now try to solve this, and you have already got the result. Have you got the result?
Yes, ma'am.
So how we can take the adjacent ones? See, here 1 is not present, so it is 0. So these 4, if there is a 1, then these 2 and these 2 ones make a quad. Right? As in this example. But here, these 2 ones are here and only 1 is here in this cell, but 0 is here. Actually, these blank cells contain 0, right? So, quad is not possible here. So, how we can solve this kind of map? If there are 2 adjacent cells containing 1, it will make pair. Is it clear?
Yes, ma'am.
Yes, ma'am.
So how many pairs are there? If we take this 2, 1, it is pair. Then if we take 1 and this 1, another pair will be there. So how many pair we can form here?
M2.
2. Another question may arise that if we take these 2 adjacent 1 as a pair, or if we take these 2 1 as an adjacent pair, only single one is remains or left here. So why will take it for the next pair? Why not we consider this one as a single term? So the answer is, if we take the pair, we can drop out the more number of literals. See, if we take this one as a single term, what will be the result? A, B bar, C. Okay. A, B bar, C. And if we take these 2 adjacent one as a pair, then it will give us A bar, and from here it is C bar, right? So you will get A bar, C bar, and if just you will take this one as a single term, not making this pair, just single term, it will be here A, B bar, C bar. A, B bar, C bar. Have you got this point?
Yes, ma'am.
Ma'am, can
So
you
if
repeat
it
it?
is A, B bar, C bar, one more literal will be there. Our purpose is to minimize the number of literals, because if we can reduce the number of literals, it will take minimum number of logic gates to represent the digital logic circuits. That's why when there is another adjacent one, so we'll take these two ones as a pair. Okay, so priority wise, first check what is possible. No, then check pair is possible. If the answer is yes, pair is possible, then take pair. If pair formation is not possible, then only you can take the corresponding min term as a single term. Is it clear?
Yes, ma'am.
So here we will take two pairs instead of one pair and one single term. So by taking these two pairs, this forms a pair, and these two ones forms a pair. The minimized form of the output expression, you will get B bar C bar plus A bar C bar, and again you can write C bar here, then within bracket you can write A bar plus B bar. But this is the last step, okay, reduced in the reduced form. I hope it is clear to all of you.
Yes, ma'am.
Just go through this part, then I will explain. Just go through this part.
Is it possible that even pair is also not happening?
If it is pairing is not happen, then we can take only the single term. Just go through this part, you will get some idea. Then I will explain it with the help of another example. So how we can take the adjacent cells to drop out this one variable, the group of 2 that is pair, group of 4 that can eliminates 2 variables, and group of 8 can eliminate 3 variables. Variables in the variables, literals. Another term is literals. So these two are now clear. I hope 2 means it makes a pair. 4, it will make a quad. And another option is if 8 adjacent cells contain 1, then it will
Octet.
make octet. Can I move? Up to this, is it clear?
Yes, ma'am.
Now, do this example, and with this example, today's class will be over. So now the time is 2:28. Okay. Simplify the following expression using the K-map. First question is, y is given, not it is given in the form of A, B, C, D or something like, but how we will get how many input variables are there? I mean, how we can guess the number of input variables? So yeah,
Yes, ma'am.
from these expressions, how we can guess how many input variables are there?
Ma'am, 4.
4. Why?
Ma'am, because 13 So
Because
it's exceeding
maximum in terms, which is 13,
13.
is present here, and to represent this 13 in binary form, minimum 4-bit combinations are required. So now y is a function of a, b, c, d. So first step is draw this Carnot map for 4 variable. Is it clear? This map is clear?
Yes, ma'am.
Now A is the most significant bit and D is the least significant bit. So A, B, C, D. Write all the possible combinations here. A bar, B bar, A bar, B. A, B bar, A, B. C bar, D bar, C bar, D. C, D bar and C, D. I hope this is clear for 4 variable Carnot map.
Yes, ma'am.
Then see the min term positions. 0, 1, 2, 3, 4, 5, 6, 7. Then skip this row. 8, 9, 10, 11, 12, 13, 14, 15. Clear?
Yes, ma'am.
Yes, ma'am.
Okay. If it is clear, then
ম্যাম 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 এখানে যে কোয়াড 3টা আছে না?
কোয়াড থ্রিতে আমি যাচ্ছি আগে, এটা ক্লিয়ার তো?
হ্যাঁ ম্যাম, হ্যাঁ ম্যাম।
Okay. Then from this equation, just place the value 1 in the corresponding min terms position. Right? So 1 corresponding cell 1, 3, 5, 7, 1, 3, 5, 7, 8, 9, 12, 13, 8, 9, 12, 13. So now these 4 ones form a quad. These 4 form a quad. Then suppose we have taken also these adjacent, these 4 ones. So how many quad are there? Quad 1, quad 2 and quad 3, right? Clear?
Yes, ma'am.
Okay. Now how you can solve it? Quad 1, it will give us
A bar D.
A bar D. Is it clear to all of you? A bar D, how?
Yes, ma'am.
Yes, ma'am.
From here you will get A bar and from here you will get D, right? C
Yes.
bar 1 and B bar give us 1. So take A bar and here take D. So it will give us A bar D. And for this quad 2, you will get A C bar. See, B plus B bar give us 1. So it will be A. And from this part, D bar give us 1. So it will give us C bar. So what will be the output? A C bar. So quad 2 give us A C bar. And for quad 3, it will give us, if we take quad 3, then it will give us C bar D bar only. C bar D. Is it clear?
Yes,
Yes,
ma'am.
ma'am. Yes, ma'am.
How? C bar D. Because here, for these 2 terms, you will get A bar. And for these 2 terms, you will get A. Then A plus A bar give you 1. So ultimately, for these 4 combinations, ultimate result is 1. Is it clear?
Yes, ma'am.
Yes, ma'am.
Achha. Then another term is C bar D. First one note is there, just read. See, why we
Ma'am,
will not consider this quad 3 for this
ma'am,
problem. বলো
ম্যাম সি বার ডিটা তো পুরোটাই কমন হয়ে যাচ্ছে, ওটা তো ক্যান্সেল আউট হয়ে যাবে না, মানে কোয়াড থ্রিটা?
এটা quad 3
সি বার ডি।
C bar D.
হ্যাঁ ম্যাম, মানে দেখো দুটো
মানে
quad
কোয়াড
আছে।
3টা।
হ্যাঁ
হ্যাঁ,
কোয়াড
quad 3টা
দুটো কোয়াড
ক্যান্সেল হয়ে
আছে,
যাবে, আমরা নেব না। কেন নেব না সেটাই এখানে লেখা
ওটাই
আছে।
বলছিলাম।
হ্যাঁ, so we'll take only this 4, these 2 quad, because here how many cells have got the 1 value? 8. Here the positions of these 4 makes a quad, and here the position, this 4 adjacent cells make a quad. So if we consider this quad 1 and quad 2, all the ones will be covered. So we can leave this quad 3. If it is, then this quad 3 is known as the redundant group, because the ones covered by the quad 3 are already covered by quad 1 and quad 2. So we should omit this redundant group. So have you got this term, redundant group, when it is called as redundant group?
Yes, ma'am.
Sia, Shunayana, or any other, do you have any doubt regarding this?
No,
No,
ma'am.
ma'am.
No. So in this situation, when all the ones are covered under this quad 1 and quad 2, then again we should not consider the another quad covering these 4 adjacent cells. But if these two ones are not there, then you will take quad 1 and take these four ones as a quad. Okay, if these two ones are not included in this expression, then you can consider quad 1, and by taking these 4 adjacent cells, it will form quad 2. Clear?
Yes, ma'am.
Is it clear?
Yes, ma'am.
So please take this problem 6 and try to solve it at home. Just write these expressions, okay? Problem 6. 0, 1, 2, 3, 4, 5, 6, 7, 11, 13, 14. Please give the attendance. Roll number 61,
Present, ma'am.
62,
Present, ma'am.
63,
Present, ma'am.
64,
Present, ma'am.
65,
Present, ma'am.
66.
Present, ma'am.
কি হলো না গো আজকে আছো আচ্ছা 66 67
Present, ma'am.
68
Present.
68 স্বপ্না আছে 68 কে প্রেজেন্ট বললে সোহম নাকি অর্ব 68
Ma'am, Sapna Kumari is present. She wrote in the chat.
okay $68 তাই তো অর্ব
Ma'am, Arbab too wrote in the chat box.
69
Yes, ma'am.
70
Present, ma'am.
71
Yes, ma'am.
71
Yes, ma'am.
কে শায়ক
Yes, ma'am. Yes, ma'am.
72
And 72 is present. He wrote in the chat box.
73
Present, ma'am.
74
Present, ma'am.
75 75
Present, ma'am.
76
Present,
Ma'am,
ma'am.
75 present.
76
Present, ma'am.
77 77 78
Present, ma'am.
79
Present, ma'am.
80
Present, ma'am.
81
Present, ma'am.
82
Yes, ma'am.
37 Dista Dista only
Ma'am,
absent Dista ki absent
And
Yes, ma'am.
present Shilo. কিছুক্ষণ আগে ছিল।
কিছুক্ষণ আগে
Yes,
ছিল।
Yes, ma'am. She was present.
Dista is present.
She was present.
Okay. But here it's not showing.
Yes, ma'am. I think she just left.
Okay. Inform her. Okay.
Yes, ma'am.
Now. Okay. Thank you.
Thank you, ma'am.